Okay, hi everyone, welcome to a brand new video. So this video is actually part of a NumPy Crash Course. So if you don't know what NumPy is, it is a Python library that is very commonly used in the field of data science as well as machine learning and AI in general. So it's a very popular library. They say that you must learn NumPy before you actually progress to the harder and tougher machine learning libraries that Python provides in order to be able to use the NumPy capabilities in your data science or machine learning code. So this is a basic idea of what NumPy really is. So the crash course will have an introduction to NumPy as well as a summary of all the essential formulas as well as the different concepts that you should learn as part of a sort of data science prerequisite. So by that I mean that you will learn how to use NumPy, you'll be able to install it, you'll be able to create different arrays and matrices with it. And if you don't know what that even means, no problem, I'll be explaining everything in depth. I'll also be explaining the conceptual ideas behind matrices, so I'll explain the math behind them as well as the code, so different type of matrix operations, the way linear algebra just fits into data science. So this is really meant to be as a sort of data science prerequisite course. So without further ado, let's get started. I'm just going to take one more minute to sort of just talk about every single feature that NumPy has, so just in a brief and concise sense. So like I said, that NumPy forms the basis for most of the machine learning libraries. It is usually what you're going to learn first before progressing through different types of libraries that will help you just finally reach that goal of becoming a data scientist. The NumPy array is actually a central object in the field of AI. So this NumPy array is a bit different from standard Python lists, and it is more computationally cheap, so it's faster and it doesn't require as much computational power as the operations of standard Python lists. It also provides more in-depth functions on the arrays themselves rather than the standard Python lists, and it has more type of math operations, and it is actually optimized for speed. So like I said, and it's popular for built-in matrices and linear algebra operations. So that's basically what NumPy is. So the first thing we're going to do is that we're going to install NumPy. So the way we're going to install it is that we're going to actually go to our command line and we're just going to type pip install numpy, and then we'd wait for it to be installed. Now obviously I have it. Also I should update pip. So obviously I have it, requirement is already satisfied, so there's no problem with that. So in your case, you'd wait a couple minutes for NumPy to be downloaded and installed on your machine, and then you can get started. So now that you have NumPy installed, you can actually get started by importing NumPy. So a standard convention is the following. So import NumPy as NP. So you don't have to import NumPy as NP. You can keep it as NumPy. You can import it as pretty much any other word in the dictionary. But this is a sort of standard convention. So most of the data science or machine learning code that you're going to read will probably import NumPy as NP. And it's always good to follow standards because one day you're going to be working with a company and you don't want to be on a completely different page than most of the coders within the company. Alright. So to get started, I'm just going to demonstrate some slight differences between Python lists versus NumPy arrays. So I'm just going to create a typical Python list, and I'm just gonna say it's 1, 2, 3, 4, 5, and this is a standard Python list. Now I'm going to create its sort of equivalent in the NumPy world. So let's say NARR, which stands for NumPy, ARR, is going to be the following. So it's going to be np.array, and then I actually should not have put this here. And then we're going to say 1, 2, 3, 4, 5. And now it's created. So by printing each element in both of them, we get essentially the same thing. So for number in ARR, print number, and then you would get it right here. Or you could try for num in NARR, print num, and then you would run it and you would get the exact same thing. So now you're asking me, what's the difference? Why is there a NumPy array versus the standard Python list? Why can't I just use a Python list for machine learning? Alright, so let me just show you the difference. So one thing that NumPy is popular for is the type of math operations that you can apply on the arrays. So here's what I'm going to do. So I'm going to say ARR plus ARR. And here's what I have. This is the result. So I'm adding the standard Python list to itself, and what I get is it gets appended to the list. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Versus if I do the same for the NumPy array, so let me just do the following, it actually performs element by element addition. And this is actually the same for pretty much anything. So you can go ahead and do ARR times, let's say, 3, and then you would print it, and it just appends itself to its own self 3 times, versus doing an ARR times 3, and it actually multiplies each element by 3. So this is very important. This is a very important distinction between the two. Here, we must understand that NumPy arrays mathematically represent vectors. So vectors or matrices. Now, I'm just typing this here so you can actually take note of this because this is super important. The arrays, although it's very similar to Python lists, they're often thought of as vectors. So when you go and you're doing your AI, if you know any sort of AI algorithms or machine learning algorithms, you know that vectors are highly used. So vectors are a very important part of machine learning and data science. So to work with vectors, you're better off just working with np.array and then creating a NumPy array. So NumPy arrays are really important to be working as vectors, right? So that should help you with the way you think of things. So that should help you by considering things to be vectors. If you want to do another thing, so if you want to actually square a typical Python list, so let's just square it. This gives you an error because you cannot square a typical Python list. Meanwhile, for NARR, if we square it, we get the following. So each element is actually squared, and the data type is an int. You can get the data type of a NumPy array by doing the following. So narr.dtype, and then you print, and this is what we have. You could also get the size of the array, so narr.size, and the size is 5 because we have 5 elements within the array. You could get the shape of the array, so narr.shape, and what do I mean by shape? Shape essentially means how many dimensions your array has. So is it a simple one-dimensional array, or is it a sort of matrix with a number of rows and columns? So here it's telling us that there are 5 columns and there is no other dimension in this case. Alright, so now that you know the basic principle of the NumPy array, you know how it works, you know how it differs from the list, you know how to just look at it as a vector. And if you're a bit confused about vectors and what they generally represent in the math sense of things, so not in the code sense of things, no worries, because part 2 of this crash course will be going more in depth into the math behind vectors and matrices. Alright, so now let's just try to generate some arrays. Let's see how we can do it, generate arrays with specific values that we want. So np.arrange, so arrange with 1r, and you could say 10, and this yields the following. You would get a NumPy array with the following. So you'd get 0, 1, 2, 3, 4, 5, and following until 10. So it's 10 exclusive and it starts from 0. So this is how you would generate a typical array. You can also choose to do the same thing, so np.arrange 10 and then multiply it by 10, and you would get the following. So you get 0, 10, 20, and then you could just manipulate things as you go. So like I said, the element by element multiplication and addition that we have is super useful in this case. You could also create some linearly spaced items. You can say np.linspace, and then you would say 0, 10, and let's say 0.5. And you would print. Actually, you're supposed to say np.linspace 0, 10, 5. And in this case, you would get what I was trying to get before. Here what you're specifying is the following. You're saying that you want the array to start at 0, you want it to end at 10, and you want 5 elements within it, and they should be equally spaced. So you can do the following. So np.linspace, and then say perhaps 10 and 20, and then you want actually 30 elements linearly spaced, and you would get the following. So this is how they are separated equally. So this is how you use the linspace to generate the type of array that you want. You can generate an array filled with 1s, so np.array let me just type here. So np.ones, and then you can specify how many ones you want. So you could say 40, and then you would get an entire array of 40 different ones. You can np.zeros is the same thing, and here's what you have. So this is how you generate some type of matrices. Otherwise, you could also, like we did before, so let's just scroll back up and check this out. You can create an np.array by doing the following, by actually explicitly typing the array within the parentheses of the np.array function. So you pass it as an argument to this function, so np.array, and then you would say 2, 3, 6, 5, 7, and then you can just close it, and you would actually get it. So these are the different types of ways that you can generate an array. So like I said, you can arrange by creating these ordered list type of arrays. You can also have different operations to manipulate the numbers. You could have np.linspace to extract linearly space the type of numbers for your array, and then you could have ones, you could have zeros, and you could explicitly state your thing. Another thing you can do is, in the first case, so let's just go back and say x is equal to np.arrange 10, and you can still, let me print x, so you can still alter some of these. So by saying np sub 0, you'd be calling this one, so it's indexed by 0 like standard Python lists, and you can replace it with a different number. You could say 7, and then I said np, I'm sorry, so x sub 0, and you could say it's equal to 7, and then you would print x, and here you go. So this is how you would replace a specific element. Now, speaking of this, you should know that NumPy follows the typical Python list rules for slicing and indexing with lists. So what do I mean by this? That we can perform the different types of indexing that we have. So if we print x sub 1, we get the following, we get 1. So NumPy arrays, just like Python lists, are indexed starting 0. You could also access them with negative indices, so print x sub -1, and here you go, you get the following, and you have 9, so it's the last one. So when we index by -1, we start with -1 here, so -1, -2, -3, and then we keep going back. We can also slice the same way we do with typical Python lists, so print x sub, let's say 1 till 3, and then we close and we print, we get 1, 2. So this is 1 till 3. Then we can do the following. We can print x sub this. I'm sorry. So print x sub a colon, and then we get all of them the way there is no slicing in this case. We can also do something else. So we can print x sub and then till 2. So starting from 1 till the index of 2, and we get 7, 1. And as always, this is obviously exclusive. So here we exclude the index 2, here we exclude the index 3. So we only take indexes 1 and 2. So I'm not going to go into more detail here because slicing is essentially the same. You use a colon to indicate where you want to start versus stop. So a colon between two different integers means that you want to start at index 1 and then stop at 3 exclusive. So you'd stop at index 2. In this case, you would say you'd start at the very start of the array or Python list and then head till index 2 exclusive. So typical Python list slicing and indexing. There is nothing new here, it's all the same. So NumPy really followed that syntax and you can actually work with it. So moving on from the NumPy array, which represents vectors like we said in math, we want to work with the NumPy matrices. So matrices are essentially just two-dimensional arrays in which we have 2 dimensions. We have rows versus columns, and they're basically just vectors of 2 dimensions as well in the mathematical sense of things. To generate a matrix with NumPy, you can just np.array, so the same function actually, and then you do the following. So 1, 2 you could say, and then you would comma, and then 1, 3, 4. And then you would have this thing. So it's also still an array by definition. So matrices in general are just NumPy arrays with 2 dimensions. And here you have the first dimension, so 1, 2. This is a row versus this one, a second row. So 1, 2, and 3, 4. So this is sort of how your matrix works. Now you can also generate matrices the same way we said before. So np.zeros, and we can say we want 4 dimensions by 4. And I'm sorry, 4 rows by 4 columns in 2 dimensions, and we get the following. So these are 4 rows with zeros within them. We can also np.ones and also create 3 rows and 3 columns. It's important to have these right here, so it's important to have the parentheses within the parentheses to indicate that this is a 2-dimensional thing, and this is the result. Now you can also access and modify these values using the following. So let's just save the variable first. So x is np.ones and 3. Okay, so if we print x, now I can say I want x sub 2, 2 to be equal to 5. Now if I print x, here we go, we have changed the last one, so it's also still indexed by 0. It's important to note that we have to use a bracket with the comma separating the different indexes. We can say print x sub 0, 0, and we would get the first corner element, and it's 1, so it's basically this one. So continuing where I left off, we can also generate a new NumPy matrix using the arrange function that we just used. So here's what we have to do. So we can say np.arrange 1 till 7.reshape into a 2x3 matrix, and the reason that is, I'm just going to explain it right now, right after I print it, but let me just first. Alright, so this is what we have. Why did I say 1 to 7 and then reshaped it into 2, 3 and not anything else? So let me just try something else. 1 till 8, you could say, dot reshape into 2, 3. And here's what I get an array. And the array that is because I have 7 different elements inside this array, and I'm trying to put it into a 2x3 matrix. A 2x3 matrix, so 2 rows, 3 columns, obviously contains only 6 elements. So by trying to put 7 elements there, I just called an array. So that's why I declared here that I want 6 elements by having an arrange between 1 to 7. So that's how you use arrange to generate a matrix. You could also just use the following. So let me just copy it. And you could also choose to multiply it by 5, you could say. Then you'd get the following. So 5, 10, 15, up until 30. So that's how we do things. That's how we generate things. So let me just create this into a variable so we can actually use it. So let's say nmat or nmate. So this is a matrix. And let's just paste this here. And let's print nmat. And we have the following. Alright, so what types of operations can we perform on these matrices? So like I said, the more math part of the operations will be in part 2 of this video. So the part 2 is going to be the math dense part where I actually explain the math theory behind things, as well as the way we do it through the code. So how about these more simple operations that what I'm trying to target in this video? So for example, to get the minimum of an array, I can do the following. So I can np.min and mat, and it's 5. I can np.max and mat, and it's 30. I can also sum them. So np.sum and mat. Well, these are the aggregation functions provided by NumPy. We can also find the standard deviation. So np.std mat. We can find the average. So np.mean and mat. And this is what we have. So if you consider your matrices as holding valuable data, so I'm just giving you some insight to the way this will be used in data science. So your matrices could hold this important data, and by applying these functions, you can extract all types of knowledge on this data. You can also perform logical operations. So let's do the following. So nmat equal to 5. What does this mean? We get a new matrix. It's also 2x3, but these are the values. So true, false, 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 false. So what it did here is it tried to verify this Boolean operation on every single element of the matrix. So it's checking, is this equal to 5? True. Is this equal to 5? False. Is this one equal to 5? False. and so on. So that's how it sort of works. You can have a different type of logical operation here. You could say np.any, and then you would say nmat is equal to 5. And in this case, it's true. So here what I'm saying is that if there's any single element from nmat that has a value of 5, return true. The other one would be np.all nmat equal to 5. And in this case, we're checking if all the values of nmat are 5, return true. In this case, it's definitely false. So these are the types of different logical operations that you can have. You can also choose to shuffle your matrix. So let's say np.random.shuffle nmat and print nmat. So here's what we have. We just randomly shuffled them 20, 25, 30, and this is the new type of order that we have. So now that we've shuffled it, we can also choose to sort it. So we can np.sort nmat. Now, one thing to note in this case, sorting happens per row. So in this case, it only sorted this row with itself, then sorted this row with itself. So that's just something to keep in mind. Meanwhile, here they shuffle as well. So it shuffles each number within one row. So here we had 5, 10, and 15 in one row. But it also shuffles the rows together. So it doesn't just randomly get a 20 from here and shoves it into this row. It doesn't alter the values within a row, but it just shuffles the order of the values within a row and then shuffles the rows themselves. So here, it just changed the order of the two rows. Alright, so that's something to keep in mind. So that's basically it for this video. These are the simple operations that you can apply on arrays and matrices in NumPy. And through these, you'll be able to sort of understand better how the NumPy array works. And this is an essential prerequisite to data science. So in the next video, I'm just going to go over the math real quick. So with a standard, typical math explanation, you could say, of the linear algebra basis for this. It will not be a tough one. It will be for beginners. And then we're going to delve deeper into the code where we'll apply different linear algebra functions on these matrices. So thank you very much for watching. Leave a like if you enjoyed, and I'll see you in the next video.